Alright, we should be getting there. This should be coming on in a moment. Alright, we should be getting there. Club. I guess this needs to be moved over a little bit. Same with this. Stop! Stop! Okay. There's notes. Nope. Oh, yeah. Well then. Okay. Facebook or... Alright then. Now we're gonna get... Now we got Facebook. Cool. I think we're ready. Do I have audio?
I think we're ready.
Yeah. Facebook, do we have audio?
Do I have audio? I think we're ready.
Yeah. Sweet. Yay! Alright, let's do this thing. Okay, so... let's make sure I have everything here. Where'd my magnets go? No, not the magnets. Magnets are the most important part. Well then. Of course I lost my magnets. What the heck? Of all the fucking things to lose. They were just here. Why? Why does this stream hate me so much? I just want to make stuff for you people. Ah, found him. Alright. Magnets. Magnets are found. Sorry about that. Alright. So what we're doing today, what you see here is an updated version of this thing. And what this thing is you can see maybe right here is it has magnets built into it, except for that one. The rest of them press fit in really nicely, but this one ended up coming out. But what this does is this. Hopefully you can see that. This is actually a, so this is a shelf. This is a metal steel shelf from IKEA. It's part of a shelving system for shelves. But I actually had extras because I wanted to merge a couple shelves together, add more shelves to a single unit, so I bought 2 units. Anyways. So I decided to make a display out of this. So I can have this, 2 of these printed, 3D printed, and then they stick, and then they hold this at about a 10-degree angle. And then you print 2 of them, and then their legs. So I already have one, and now I have this extra shelving piece. And I want to make something different. And what I do need, actually, at the moment, is a monitor shelf for my desk so I can lift it up. I'm thinking about 5 inches. I've already done a few measurements. About 4 or 5 inches. And then my goal is to just make 4 legs for this in kind of this manner. So we have rectangular prisms, probably square on top, and then a little bit, and definitely longer than it is square. And then we do this. Here's 1, then we do 2, 3, 4, and then we have this shelving unit that goes around it. And then to get that stuck in there, I have these bigger magnets. Unfortunately, one of them broke already. These are very large and very tough magnets. They're thin, but they're very wide, and they stick on really well. So those are going to work really well. We'll have to measure those, and this square will probably be just a bit larger than the top portion of that design. So I wanted to show you an initial design. This is my original design for this bracket, and we're going to use some of the similar things that I learned making this. This took me maybe 20-30 minutes to make, so hopefully we can get this done in about 10 minutes or less. So this is, I just wanted to go through kind of a little bit of my design theory while I make this piece right here. So I'm gonna get this, slide this over a little bit so we can have a little bit of space to work with. And we're gonna start with a new file, a new design in Fusion 360. And usually what you want to start with is you always want to make sure that your axes are correct. So if you look at the top corner up here, you'll see top, right, back, front. What you really are mostly concerned about is the top and how you want to orient your item. In this case, it's not really a huge deal, although we do want the cavity that's going to hold this to be either on the top or the side. If we do it underneath, we'll have to cross what's called a bridge and potentially have to use support material in the process, which is extra material to keep the 3D printer from printing in midair. So ultimately, I think we're just going to go simplistic here and start with just measuring the diameter of these magnets. Unfortunately, magnets have a tendency to stick to the calipers because the calipers are also metal. Let's make sure our calipers are zeroed out. Close enough. And we're just going to stick that in there, and I get a measurement of about 32 millimeters. Now, I want to give myself about 0.2 to 0.3 on that diameter of space, but we're not quite there yet. So our actual diameter is 32, so we can keep that in mind over here. I do want to start with, so we always want to start with a new, create new component. And we do this potentially for future options. So Fusion 360 actually has the ability to take multiple components and understand that these are parts of a whole, and you can actually start messing around with assemblies and hinges and how things interact with each other. And it actually has a physics engine built in, I believe, but we're not there yet. But it's always just good practice to make sure that each part is a component. That way you can always come back to it. And usually I don't necessarily name these unless I actually have multiple components in here. Then what we want to do is start with a sketch. We always start with a sketch. We want to start with a flat non-dimensional, a flat two-dimensional object that has no third dimension capabilities to rough out our shape. So I'm going to start with actually just a square. So I'm going to start with the rectangle and our, well, first we need to define our sketch plane. So we're going to do that on the bottom because we're going to draw the square and then we're going to extrude it upwards. So start with a square in the corner. And remember, our dimension is 32 millimeters. So this has to be larger than 32 millimeters. And I'm going to give it about, let's say, 2 millimeters on each side. Does that sound about right? Let's see what 2 millimeters looks like. 2 millimeters on each side, so we want to do 32 plus 2 plus 2 on each side. So 32 plus 2 plus 2 would be 36. 36, and then 36. And then we want to ultimately just extrude this upwards. So I'm actually going to stop this sketch right now, and then what we do is we go to our extrusion, and then we select this, and then we want to start giving it a direction so we know if we're going to positive or negative space. I want to start at about 5 inches, so I'm just going to convert 5 inches to millimeters. Hey Siri, 5 inches to millimeters.
5 inches is 127 millimeters.
127 millimeters. This is going to be a large print, actually. So actually, let's do 4 inches and see if we can get away with that. So let's start with a smaller piece and then add to, like, reprint it afterwards, rather than doing a large piece and having to print less afterwards. So we end up with less waste, theoretically. Hey Siri, 4 inches to millimeters?
4 inches is 101.6 millimeters.
That's good enough. Let's do 100 millimeters. Cool. So this is basically our part. Now what we want to do is an additional piece going in to embed, so we can embed these magnets in the part and they're not just sitting on top. So first of all, I want to get the thickness of this magnet. I have 1.54. So I'm just going to say 1.5 is our thickness of this piece right here. Not necessarily our final dimensions though, so we will keep this in mind. But what we're gonna do is we're gonna go into our sketch menu. We want a new sketch, and we want this sketch to be on this top plane right here. Yes, calipers are excellent. And then what we want to do is we want to sketch a circle from a center diameter. And then what I want to do is actually, if you'll see, I'll zoom in just so we can kind of see what's going on here. If I hover my cursor towards the middle point, it'll actually stick there, and then I can start coming out to the middle this way. And then if I come up here and then get that same triangle icon and then come down, we can actually put that centerpiece, that center point right in the center, and then we'll be working with the diameter of the circle. Now we have 32 millimeters as our diameter, and let's just double check that just for safety. Is what we're getting, yep, pretty much exactly 32 millimeters. So I'm gonna want to actually make that 32.3 millimeters. There's slight variation in the 3D printing process that you want to take care of, and just in general, one of these magnets might be slightly off than the other ones. There's variation in manufacturing, so 0.2, 0.3. I'm going to start with 0.3. This isn't an extremely this doesn't need to be an extremely accurate part, so 0.3 just to make sure that my magnet's going to go in the hole. So 32.3, and then now last time you saw me just stop the sketch first, but we can actually click on this and then go to our extrude immediately, and this time, let's see if I can get this angled right this time. So you see it's gonna want to go up, right? So if we go up on this, it's going to be positive numbers, but we actually want it to go in, and it's going to go from a join operation. So if we do this, it's actually going to join those two pieces together. It's actually going to, it sees two items and then it wants to smash them together into one, what's called a body. Our bodies are over in this location right here, but we actually want to go inwards, and we're going to do a cut operation. Now that's 1.5. I'm going to do 1.7. I'm going to do 0.2 just because I would like to make sure that the magnet is as close to the top as possible, and we'll see how that goes in actual 3D printing land. Cool. That did not do the thing that I wanted it to do. It did it? Nope. For some reason, got fucked all to heck. So, extrude. Oh, because I put in a positive number. That's why. So I wasn't paying attention and I put in a positive number. So I want negative 1.7 rather than positive 1.7. And you don't really have to put in millimeters because our default scaling is in millimeters, so we can just do 1.7, and there is, let me put some wireframes on here. Visual style, shaded with visible edges, but we do shaded with hidden edges. And then there is our piece. Now, thing is, now we just have one big block of square plastic. Now in the 3D printing software, it is going to do what's called an infill, so I can specify like 20% infill, and it's only going to fill in, it's going to do a special pattern on the inside to make sure that only 20% of that is filled in. But let's make this interesting. Let's actually like manually remove material like we did in this display bracket over here. Sorry, my hand keeps hitting you. I'm using the pen on my Surface. So I just went in and actually just drew out some pieces and then just used our extrude tool. So I'm just going to do the same thing here. We're going to do a new sketch and choose this side. And then I'm just going to use the line tool and I'm just going to draw shit. So L, now I am being careful to give each little area its own amount of space, a good amount of space. This can be a parallelogram. And then, sure, why not? Let's throw in a triangle at the corners, bottom corners. Like that, actually. Yeah, I do want to give a little bit of space on the edges here. Might be a little bit too much, but you know, we'll see how this works, and if eventually my mechanical engineering isn't quite perfect, then we will come back and redesign it. But it seemed to work pretty well on the other one. Now we'll see here, I actually just realized this right here, that's the bottom, I believe that's the bottom of our hole. Yep, it is. It is indeed. So I'm actually going to want to move this point a little bit over. So I'm going to just kind of go in here and then zoom in a little bit and see what I can do about this. We want to get rid of, we want to right click that. I'm going to move. I'm going to move this down a little bit. Does that do anything? Nah. So for some reason, sometimes this shit just does not want to get moved. So I'm just going to redraw this. Sometimes it's just better to just redraw some of this stuff. L for line up to here. Maybe a shift to keep it straight. Yeah, there we go. Made a few modifications that weren't too bad. Let's get back to filling the rest of this out and seeing how this turns out. I'm pretty stoked about this actually. So L for line, do a line like this, line like that, maybe a line like that. Yeah, I'm gonna go back up on myself like that. Yeah, just shapes. Just some shapes. I'm gonna do a wonky shape here and get some nutty stuff going here. Yeah, this is gonna be fun. Probably not conducive, but who gives a shit? Alright, a couple more shapes here, and then we should be done with that side. Do a little square like this. And let's do this. This may actually need some serious support material though, now that I'm thinking about it. Because I am going to do it through the other side too, and oh, this is just going to be a mess, isn't it? Oh well, we'll see what this looks like. Let's see if I want to stop this sketch because my thought is to do it again on this side. I'm not sure there's actually a way to duplicate. Yeah, it's all a big iterative improvement process. Absolutely it is. And so what we're gonna do is so this side is gonna go through to this side. And in fact, let's just take a look at what that looks like real quick. So I'm just going to start selecting these little boxes, the little shapes that I made. And then we're going to modify, and then we're going to actually extrude to the other side. Now I can actually just tap this face and it'll come right through. So we're good right there. That's actually not too bad. I think that, oh, that's that's pretty. I wonder if I just leave it like that. I think I'm just gonna leave this like this, actually. I was thinking about going through the other side, and I might still do that, but I think I might do that off camera, because I want to just get you guys to the next step right here, because this is actually quite beautiful, and I think this is going to look great, even by itself. So, yeah, so we've basically got our design down, and what we want to do now is actually throw this into our slicing software, which is Cura. So actually, it's just what I use right now, but so we go up to the make command, and then we select our item that we want to export, and we're going to export it as an STL file, but we're actually just going to go straight into the application, and what you'll notice is that it shows you the different triangles. It's basically creating a mesh. This doesn't actually have any like inside or outside. It's just the shell of your object, and then the slicing software can actually determine what to make solid and what to make not solid, so on and so forth. So we're actually just going to pop this into Cura, and we're going to wait for Cura to pop up. Might take a minute. I'm just going to drive. Okay. Continue. Continue. Okay, Cura, what do you want from me? Alright, we're gonna do this a different way. Sometimes Cura is a little footsie. So we'll just send this to the desktop as leg 1. Call this magnet leg 1. What do we call it? Magnet leg 1. Save. Alright. And go to our file explorer, go to desktop, and magnet leg. See if that works. Yes, I want to open with Cura. Cool, now Cura is opening, which is good. Who gave me a sad face? Ah, there we go. Here's Cura. Right, Cura, how are you doing? So, this is where your orientation is important. Now, to tell you the truth, so what you'll see here is you'll see some red zones where it's just not happy with me about this situation at all. So, seeing that we kind of cut through the majority of it, I'm going to reorient this in here, because actually I'll show you. Let's see, support, yep, and then we want to go to our layers mode, and then you'll very quickly see once it's done slicing. We've got a lot going on this machine right now. Processing layers. Yeah, so this is all support material in there, and then if this was solid, it would just not have done anything on the top. And I think this will print. I think this is gonna print a lot better on the side because it wants 4.5 hours to print this the way it is right now. And let's see what happens when we get rid of the necessity for all this support material. So I'm gonna tap on this, I'm gonna go to rotate, and I'm gonna rotate this 90 degrees. That's gonna go flat. Still wants 3 hours, which seems a little extreme to me. Let's see what our settings are looking like right now. Now we're going to do this in PLA. Silly pen does not want to work. So we got a layer height of 0.3, which is rough, but it's probably the largest layer height we would want to go with a 0.4 millimeter nozzle. Wall thickness of 0.8, which is two walls, which we use our nozzle diameter to figure out. So 2 walls, and then you'll notice infill. So infill, I was talking about infill earlier, and you'll notice. Let's see if we can get this shown a little bit better. Yeah, it's still... Problem with Cura is it always likes to slice. Alright, so this is what our top layer looks like. We have a couple top layers. And then when we go down into the layer stack, you'll actually see a pattern on the inside to keep all of that stuff, to keep everything together, but not have to fill it with 100% plastic. So that's what our infill is. I think 20% is good. It's actually pretty steep for something like this, but I think actually not so much. I'm gonna do a one-off and see where we are rather than printing all 4, and then we'll come back in another couple days and maybe I'll show you how it turned out and so on and so forth. But yeah, I'm pretty stoked about this. I've been trying to figure out a good solution to how to use this piece of shelving as a monitor support so that I can put my keyboard and mouse under it and do non-computery things on my computer desk. Because if y'all saw one of my episodes a few months back on my YouTube channel, I replaced my standing desk tabletop with just straight plywood so I can bash the shit out of that fucking tabletop and not have to worry. But it becomes quite messy and I need a little bit better organization, so I think this is going to be a good initial solution for that problem. And with the tools that I have, this is gonna print in 4 hours. It's a long time. Yeah, that's a long time, but we'll see how this turns out, and then we'll print 4 at a time, and then that should just be an overnight job and we should be good. I'm done. This is good. We're good. And I just wanted to get this out and show y'all kind of like a design process that I have. Something that you can just do. I'm not particularly an artist, but when I did this triangular bracket and was able to just throw some shapes in here and have it turn out and look really, really cool, I wanted to do it again, and I really wanted to capture it on camera, and this turned out really cool as well too. It doesn't look so hot when it's just a sketch design, but once it gets that dimensionality and goes through the item, it just looks so cool. So I'm glad you were able that I was able to get this up as a video and do it as kind of more of a live video. I'm going to be doing less and less, you know, pre-recorded high production value videos because I just don't have the time to do it. But if you do like more of these would like to see more of these live videos that I'm doing, please let me know. And also, I have a Patreon. I am Clomads on everything that you could possibly imagine, especially on Patreon. Instagram, Twitter, Facebook, YouTube, CLOMADS. I run a store called Queered that helps queer and trans people of color with their art, promote their art, and then hopefully in the future we will be able to get a maker space. So we have a bunch of t-shirts up there, so please buy a t-shirt and help us support queer artists and makers. I'm Chloe again. I'll see you in the next one, I guess. Peace.